that easy. But yeah, it is also not that tough. Kind of moderate
Yeah,
thing.
right, right.
Yeah.
Okay, let's see. I mean, this topic will be again will be appearing in your answer.
In terms. Yeah.
Yeah, right, right. Okay, so I mean, after the exam, have you solved the quiz to paper? Anyone? Have you went through the quiz to paper?
Not actually, but because quiz 10 and quiz 11 content, week 10
Week
and
10
week
and
11
11.
contents were released, and only four lectures in it took ample of time to assimilate week 10. I have still not started week 11. And sir, I want to share one thing. One problem with the lectures actually, which I think at a student level, I should share with you.
Can you repeat?
Uh, Sir, in lectures, while uh, watching these lectures, there is one problem which I want to share. Actually,
Yeah.
theoretically, we are able to see that, say, where the unit vector is, where all that is, but there is no diagram being shared in the lecture, so that I am not able to locate the position of where is the point, where is the line, where is the unit vector line, and in which direction we are going.
Okay. Okay.
Uh, I
But
want
there was GeoGebra presentation in the lecture, right?
Yes, sir. Later on in week 10, when I went through the later lectures, like week 3, then I was able to get some idea about where the actual positions of these points could be. But I want to share with you that
Okay.
there was a derivation in lecture 1, the equation of a tangent line. Or
Right.
it was in, I think, lecture 2, the
Okay.
equation of a tangent line. So theoretically, it was explained very well, but without a diagram, it was a bit difficult for me to assimilate the concept.
Okay. Okay. Having, I mean, in tutorial, I think there are diagrams or something, right? In lecture, I agree. There should be more diagrams in the lecture itself. That's I completely agree with. So in tutorial, have you? I mean, was your doubt got little bit cleared or no?
Sir, actually, I was not able to go through the tutorials.
Okay.
I only finished it today
Okay.
for
You
lectures
are
2.
you attended my last live session, right?
Yes, yes.
You were there, right? Yeah. Okay, fine.
Also, I have a question. So in stats 2, we get a formula file. So why it is not provided in maths?
Because if even there is actually no formula in maths 2. Can you point out the formulas in maths 2?
For some of them, like um, the length of the norm and or like the parametric form of the tangents.
In week 10, 11, there is, I agree. But before that, I mean, the linear algebra portion, were there any formula as per se?
Kramer's rule and everything.
That is not formula, no?
Procedure.
That's the procedure. So that's an algorithm that you know, right? I mean, there is no point in giving the formula. Even, I mean, there are not many questions in from Kramer's rule. We are just testing the concepts in every quiz and exam. So if your concepts are clear, I think that's okay. That's fine. You don't have to apply any formula to solve the questions of maths rule. That I can assure you.
Okay, okay.
Right?
Sir, do we get the solution for this quiz too?
You want the solution for quiz 2? Then
It's
we can
already
upload it.
posted, so
Answer key is posted,
it's
but I
all.
Yeah.
think he is talking about
No,
detailed
the
solution.
solution is already there.
Oh, okay. Is it? Okay.
Like,
No, I have not
Okay.
found it.
by solution, do you mean the working of it
Yeah,
also? I
exactly.
mean the correct options. That answer key is there. Okay,
No, not answer
okay, fine.
key. Like the way
That
we
I
get
didn't
for
see. Okay.
graded assignments.
Detailed
No,
Yeah, that
solution.
I didn't see. That I didn't see. Yeah.
it will be
Uh,
great, sir, if we can get that.
okay, so let's see. I mean, Yeah, okay. So we can
So
see
one
that.
more thing can I share, sir?
Yeah,
You
yeah.
were asking about you saw drastic change in the results between quiz one and quiz two, right? So one
Right.
thing I mean I don't know. I am probably assuming most of the questions were numerical answer type in quiz two. There were no select or
Ah,
like that. That is
right,
one
right.
thing I would see, and also like comprehensive type questions wherein if you only understand that question, the complete set will be correct. If you have I mean if we have misunderstood any concept anywhere, like even one thing goes wrong, the complete it was like one comprehensive type question and many questions follows that. So I think that should be one reason for this result.
Okay. Yeah, that may be. I mean, the numerical answer type was intentional. We wanted a numerical answer type question in quiz two. That's intentional. And yeah, comprehensive type. There are many question in a single. I mean, using a single data, we are given a lot of questions. That's what you were saying, right?
Mm-mm.
Yeah. Okay.
Yes, sir, that's what I was saying. Oh, the results out, sir. I don't see the result.
No, no, result is not out yet, but
Okay,
I think by tonight or tomorrow morning you will get that.
okay, fine, sir.
Okay. Okay. So let's see. So one thing, you will upload the quiz to solution, but any of you, if you want, you can provide a solution to the portal itself. I mean, you can send a solution to us and we can verify it, and then your solution will be in the portal. That can happen. Otherwise, we will upload our solution. That is also
Thank
okay.
you, sir. Thank you so much.
How do we
Yeah.
send to you, sir? Through mail or?
Yeah, if you want to send your solution, then just send a mail to me,
Okay,
shubhajit at the rate onlinedegree.iit.ac.in. Okay. Then
okay.
I
Can
will
you
see
put
your
that in
solution.
chat, sir?
Yeah, I will
Okay,
give that.
thank you.
So basically, then I can see how you are approaching the problem. That will be good for me also. Yeah, you can send it here. If you want. Okay. So do you have any doubt till the last session we have discussed? So in last session we have discussed about limit, a little bit about continuity, uh, gradient, partial derivative, directional derivative, and also tangent plane and tangent line.
Yes, sir. I am stuck in this tangent line derivation.
Okay.
Same problem, sir. I am not able to visualize it. Where is
Visualizing tangent line, is it?
tangent? Yeah, yes, sir. Suppose where is the point lying? Where is the unit vector pointing? And where we are having the tangent? And how we are writing like this thing xt is equal to a plus tu1 and b yt equal to b plus tu2.
Mm-hmm. Okay, fine. Can you see my screen?
Yes, sir.
Okay, let's see. Let's start with this maybe. Huh. So let's start with the visualization first. Okay. Okay. So this is the function I have plotted here, which is x square plus y square, right? So the plane in gray color, which you are seeing horizontal level, that is basically your xy plane. So the function is of two variable, as I have said earlier. We are concerned about all those type of functions. So this is x square plus y square, this function. So can you tell me, suppose I am giving you a point, okay, 1 comma 1, right? And I want you to find a tangent line at that point. So can you tell me any particular tangent line at the point 1 comma 1 if I don't give you any other information?
So y minus y coordinate is equal to slope into x minus x coordinate. That should be one tangent if I know the slope.
So suppose, so you can see the point here, right? Here is the point. Now, if I want to, want to find the tangent line without giving any other information, there can be infinitely many, correct?
Yes.
Yes,
So,
infinitely.
there are infinitely many tangent line, and all those tangent line. But the common property is all those tangent line will lie on a plane,
Yes.
correct?
Yes.
All those will lie on a plane, and that plane is called tangent plane, correct?
Yeah.
Okay, so can someone just take a sheet and work out what is the equation of tangent plane at this point? And then I want you to answer that question. What is the tangent plane of this function? So let me write it here. My point is 1 comma 1. Okay, so first find the tangent plane. How the tangent plane should look like? Any plane in 3D should look like,
So answer to 2x plus 2y minus z is equal to 2.
huh. So what is the coefficient of x here?
2a.
huh. 2, basically f of x, right? F of x at this given point, correct? This is a. What is your b? Fy of a comma b. Okay, fine. So if we write down the equation, what it should be, and it should pass through this point a comma b, right? So a minus b, y minus b, then what should be the other one here? Z minus f of ab, correct?
Yes.
Okay. Okay, so if we follow this, in this case, what is f of x at 1 comma 1? It's 2, right? F of y of 1 comma 1 is also 2. And what is f of ab? F of 1 comma 1, that is also 2, correct? So it is 2x minus 1 plus 2y minus 1, z minus 2. So what I am getting is 2x minus 2 plus 2y minus 2, z minus 2. So eventually I am getting 2x plus 2y minus z equals to 2.
2.
Correct? This is what we got. Everyone got this?
Yes, sir.
Yes, sir.
Okay, fine. So the point is all the tangent at this point, all the tangents. So our graph, our surface is looking like this. So this is my x-axis, this is y-axis. And here is somewhere 1 comma 1 comma 2, this point. So whatever the tangent line is, it should lie in this plane, correct? So let's see how this plane look like in GeoGebra. 2x plus 2y minus z equal to 2. So basically this is the equation which I have written here. So this will be the tangent plane. Can you see this?
Yes.
So you can see that this plane basically passing through the point, given point 1 comma 1 comma 2. Okay. Now, if I want to find some particular tangent line, what should I mention? I should mention the direction of the tangent, right?
Yes, sir.
I
Yes,
should
sir.
mention the direction of the tangent. So for that, so in earlier class we have discussed this one. So when we are talking about tangent line, so the point is required, and also we require a direction of unit vector. Okay, some unit vector is given, and along that direction I need to find the tangent. So let's come back here. Suppose I want unit vector, I can take at any point, right? Unit vector means just norm should be just one, right? Length one, basically. So suppose I have a unit vector here, any direction it can possible, right? This is a unit vector. Now I can transit this unit vector to here, which is parallel to this, and then I can, so there is my tangent plane. So I have to find a tangent which is basically in this direction. This direction of the unit vector should be parallel to the tangent line. That is the point. So if I have a unit vector, if I have given you the direction, unit vector means what? I am giving you a direction in which I want to find the tangent line. If I want to find the tangent line in this direction, you will give the tangent line like this. If I am giving you the unit vector in this direction, your tangent line should be like this. Okay, so depending on the direction of the unit vector, your tangent line will change. That is the point. Is it clear? So that is why when I am talking about the unit vector u1 and u2, the tangent line, I mean the equation of the tangent line should depend on this u1 and u2. And how it is depending? Basically, so I have said in my earlier class that the equation of a line in 3D should be has two constraints. Should have two constraints. It should be like x function of x equal to function of y equal to function of this, something like this. So two equality should be there. So if you see the symmetric form, that will give me the equation of the tangent line. So how it will depend on the vector? So let me write it. So my point is a, b, and f of a comma b. So first of all, the line should go through this point, a, b. So line contains this point. And what will be the direction of this? It should be u1. Then it should go via b also, I mean a comma b. So what should be the direction? It should be u2. Now for the z coordinate, what it is? Z coordinate, it is nothing but the directional derivative of this function. Basically, the rate of change at that point along that direction that we need, right? Tangent, basically, when in one variable, what does tangent do? So if we like this, at this point, what is the tangent? Tangent will be like this, right? So the slope of the tangent is basically same as the derivative at that point, correct? You remember that in one
Yes.
variable?
Yes.
So basically the rate of change of the function at that point is basically the slope of the tangent, correct? So similarly here, a direction is involved. So the rate of change of the function. So here function means we get a surface in 3-dimensional. So the rate of change of the function along that vector. Now the rate of change can vary depending on the direction of the vector. That's why we are concerned about directional derivative. That is also I have mentioned in the earlier live session. So I am recalling that basically. So the rate of change of the function along a direction of a vector. So here my vector is u, which is
Sir,
basically
may I pause
u1,
you for a
u2.
moment?
Yeah.
Sir, you have written x minus a upon u1. This means
Huh.
that this is, you said this is in direction u1. That means we are taking along x axis, right? Along the
No,
x
I mean this
direction.
all together gives you the equation of the straight line.
Yeah, I am talking about the first coordinate. Suppose we are.
This is not a coordinate, no. This is basically so see here three things are there, x, y, and here is fxy, correct? So
Yes.
here is your surface. So this is along the x coordinate when we are talking about. So here the point is a, b, and f of a, b. Okay. So these together will give you the rate of change along xy plane. Then we are coming to the z axis, to the function itself. There we need the directional derivative of the function. Okay.
Right.
Okay. I mean, this is not a single piece that I want to
Yeah, sir. This is I understood
emphasize on.
that this is not a single piece, but
Hmm.
while calculating along the x-axis, we are taking the x coordinate of the unit vector. That is what
Yeah,
I.
exactly, exactly, exactly. Right, right. Okay, clear? I mean, that has to be anyway, because if we take any unit vector, now suppose you have xy, so you know your standard unit vector, right? So that's how you have written. Now you have some other unit vector u1 and u2. Then you are expressing this in terms of xy basically, correct? This is another unit vector. You are
Yes, sir.
expressing
Yes,
this, so
yes,
that's how it is coming basically. So instead of xy, you are expressing u1 and u2 in terms of this.
yes.
Yeah. So yeah. So that's why this directional derivative is coming, because we need to know how the rate of change of the surface, rate of change of the function along the direction we need. So that's why this thing is coming and in the z coordinate basically.
So now I understood that when the unit vector will change, the direction will change, and the tangent will change.
Direction, yeah, right. So this is called symmetric form. Okay. Now, how the other two forms are coming, that is quite easy. So these two are equal. I mean, there are two equalities in this picture. Now I am assuming these two equal to t. Say. So what is this t? T is some parameter, right? Why it is parameter? It is not constant because it depends on a comma b. It depends on u1 and u2. So once any of these changes, this t will also change. So we cannot say t is constant. T will change, but when we fix a comma b and u1 comma u2, this t will become fixed, right? I mean, it will only the x will be function of t alone, right? In that case, because a and u1 are fixed, b and u2 are fixed. So x will be a function of t, y will be a function of t, and z will be a function of t. Correct? So that's why t is called a parameter, and then we know what is parametric equation, parametric form. So parametric form is basically you take this on the other side and you writing x equal to a plus t u1. Now, as I am saying, it is a function of t because a and u are fixed. So you write xt. That's how you are writing it. Okay, parametric form. Similarly, what will be yt? Yt will be b plus t u2. And what will be zt? Zt will be f of a comma b plus t of a u. Okay, so this is the parametric form.
Sir, I have
Clear?
one doubt, sir.
Hmm.
Sir, in symmetric form, how have you written x minus a upon u1? Where is it x minus a coming from?
I am not getting your question.
Sir,
What?
in symmetric form, the first
Huh.
component you have written x minus a upon u1.
Huh.
Sir, how have you written this x minus a?
Because it
X,
has it. I mean, this function. I mean, this tangent line has to go from a comma b comma f of a comma b.
yes, sir.
Right. So if you have learned, uh, I mean, that's a derivation which I was avoiding. It is not required basically, but still I am saying. So straight line in 3D, if you 3D geometry. So if you see that, so how straight line in 3D geometry is coming basically. Suppose you have a straight line which is passing through the point a comma b comma c. Okay. So basically, then x minus a by some direction cosine at this. This is called direction cosine, and y minus b again some direction cosine, and z minus c again some direction cosine. This will be the general form of straight line. And like in 2D, you see y equal to mx plus c, right? This type
Yes,
of form.
Right.
So in 3D, the form will become like this.
Okay. Now the direction is in the unit vector
So
is dvector.
direction is, yeah, right, right. So it is depending on the unit vector in which we are talking about. That's why the direction
Okay. Okay, sir.
came below.
All right.
Okay,
Right.
got it, no?
Yeah. Yeah. Got it, sir.
So suppose in 2D, you say suppose you have this point, and I want you to find the equation of a straight line which is passing through this point. Then what you will write?
So
And
I
slope is m. Slope is m. Then how you will write it,
so, it is y minus b
Y
is equal
minus
to
B.
m into x minus a.
right? So basically, you are writing it like x minus a by 1, y minus b by m, right? This is also a form which we can talk about, right?
Okay. Okay. So
Now,
now,
can you see the similarity here?
yeah, in 3 dimensions,
Yeah,
right. So, got
exactly. It will be extended version of that.
it. Okay. Thanks.
So I am not giving you concrete proof because that will be
No,
messy
no, sir.
and
I
not
have
required.
I understood
But
either
yeah,
symmetry.
you can find the analogy, right? Why
Yeah.
this type of
Yeah.
form has came, right? Yeah. So this is exactly the same thing we are doing here. Okay. So yeah, good. So parametric form, have you understood? Everyone, till parametric form, do you have any doubt?
Yes, sir.
Yes.
Okay, fine. So now there is another
No.
more form that is called vector form, right? Now vector form is as a writing as a tuple x y z. So it is x t y t z t. You are writing it as a tuple. So what is your tuple? You have already seen t one, b t two, t a fu a b. Correct. Now this is using general vector addition in R3, usual vector addition. So I can split it up. So I am getting this. Okay. Now you can again split it up by basically taking the scalar outside here, t outside. So it is. So basically this is like your y equal to mx plus c form, no? Kind of that type of form. So this is the vector, and then this is the point basically in which at which you are calculating the tangent line. This t is the parameter, and this is the direction for all the coordinates. So this is called the vector form. Okay. So if you just see, if you just find the symmetric form, then all the other form you can easily derive from that. No issues on
Sir,
that.
you have written this vector form from parametric form, right?
Yeah, vector form we have written from parametric form, and parametric form we have written from symmetric form.
So, right.
Okay. So if you remember the symmetric form, I mean, no, I don't suggest to remember, just understand the analogy and point it out. So if you get that symmetric form, you can directly find the parametric form, and then you can find the vector form. Okay, fine. So you can see why the tangent line depend on the unit vector, why the unit vector is required. Clear?
Yes, sir.
Excuse me, sir.
Okay. Yeah.
Sir, I had a quick question about I couldn't find one partial derivative. Like I had a problem in partial derivative when suppose we find a partial derivative with respect to x, then
Mm-hmm.
the other y part or z part remains. We consider them as constant, right?
Mm-hmm.
So in if can I give you a question, a small question, if you can partial derivative with that, but doubt will be
So
clear.
you want me to calculate the partial derivative?
Yes, sir. Because yes, sir.
Okay. Okay. Tell me.
Sir, f x y and the three, yeah, x y and z also.
Okay.
the derivative of x y square z cube z cube, yeah, plus 3yz.
Okay.
And now if I want to partial derivative with respect to x, then what will be the
X.
yeah.
Okay. So I want all of you to calculate it. Okay. Then we can see what is the answer of this. So can someone tell me what is the first thing? If we
Square ZQ.
Y
Sir,
square
it is y square z cube.
y square z cube, because this whole term is constant, so only x is the variable here, and if we differentiate x, we'll get 1. And this part is also constant, so it is 0, right? So this is your fx.
Yes, so if we consider like x, the whole y in the first part, the y square and z cube is constant, right?
Uh-huh.
So we write as it is, but the next term it is also constant, but we will
Huh. This is
consider
also
this as
constant.
zero.
So
Why is that?
what is the differentiation of constant?
Well, definition
What is
of
the
constant is
derivative of
zero.
constant function?
Zero.
0.
But in the first term we don't.
First term is like ax. A
Acha,
is a
acha,
constant and x. So if we take the derivative of it, what will
acha,
be?
acha,
It
yeah,
will
yeah,
be
yeah,
a,
I forgot. Sorry.
right? Right?
Yes, sir.
Derivative of
Yeah.
x power n is nx n minus 1. Here the power is 1. So 1 into
No,
x.
he was confused with this coefficient.
Yeah, that's right. Yeah.
Yeah, got
And
it, no?
yeah, sir. And can you give one example of scalar value where multivariable and vector value I'm not understanding.
Scalar value.
Scalar valued multivariable and vector
Okay,
value.
okay, yeah. Anyone want to try? Can you give me a scalar valued multivariable function? Suppose
Sir,
two
x square
variable.
plus y square plus
F of
z
x y
square.
is equals to x square plus
Yes.
y square.
X square
So
plus Y square.
and what is vector valued?
X square plus y
Vector
square, comma x
Yes.
plus y.
X plus Y.
So basically, in multivariable function, right side always be Rn where n is greater than 1. Okay.
Acha.
So Rn to R. If this happens, this is basically scalar valued function.
Acha.
Okay. Why it is scalar valued? Whatever the value you put in xy, you will get a scalar here, a constant number here,
We
right?
are getting only one value.
So we are getting a scalar basically, right? That's why it is scalar valued. And what is vector valued?
We give to
So it is Rn to Rm, and both n and m should be greater than 1, right? So this is a vector value because here basically we are getting a vector, not a scalar, right? A tuple we are getting,
here
correct?
a and name should not be equal.
It can be equal. Here in this example, n and m are equal, no? R2 to R2,
Yes.
if R2 to R2, right? This can happen. Why
Got
it should not be equal? It is a vector value function,
got it.
okay?
And so
So
from
x, y, and x star.
Rn, what is going?
Huh?
If it is from R to Rn, then what it will be called?
R2 Rm. Then it is not multivariable, no? It is a single variable function. Single variable vector valued function.
Yeah.
Okay? Okay.
Thank you, sir.
Okay. Good.
So,
1 minute. I should mute all, then I am taking your question. Huh. Yeah, now works. Hello?
so,
Yeah.
what are differentiation of tan inverse x?
So you can find this anywhere, no? Why are you asking this?
Excuse me?
What is differentiation of tan inverse x? Someone tell me.
We can X square
1 by
X.
1 plus x square. You can find it
Oh,
any formula book. You can find it.
oh, okay, sir. Thank you.
Okay, fine. Okay, so I hope there is no doubt till tangent plane, right? Now, the next topic which we are going to discuss today, that is called critical points. So, do you remember what critical points were in one variable calculus?
Yes, sir. The where the graph of the
Yes,
function turns.
it changed.
When there is a sharp turn.
Turning points actually.
There is a sharp
Turning point.
turn.
But that is turning point.
Uh, okay, turning point. What is turning point?
There is a f
A
of
turning point is the
fx
point where
When the
the slope
slope
changes from
changes.
positive to negative and negative or negative to positive.
Slope changes to negative to positive or positive to negative. So basically, slope of the function, right?
yes.
Yeah. So is there any relation with tangent and critical point?
So at critical point, the slope of
At
the
critical
tangent is
point,
zero.
tangents are not defined.
Tangent is 0.
Differentiation is zero, right? At that point.
Yes.
Yeah, right.
So slope
So
is 0.
basically, the slope of the tangent will become zero. That means the derivative of the function at that point should be zero. That are called critical points, right? So in one variable, we have seen f dash x is 0. So if dash a is 0, then a is called critical points. So what should be the analogy in multivariable?
f of x, f of y, f of z equals to 0.
Why? That is okay
The slope,
because here, but why we need all this to be 0?
Because it is a
So,
plane.
because slope, it is a
basically
yes.
the tangent plane should be parallel here, right? Parallel to the xy plane, right?
Yes.
At in one variable, what was happening? So if I draw something like this, so tangent line was parallel to x-axis, correct?
Yes, sir.
Now here, what will happen?
It will be parallel to XY plane.
So so the plane will be parallel to xy plane, correct?
Yes, sir.
So this is my xy plane and this is my tangent plane. Now, the equation of tangent plane, we have seen that it was like this, correct? So if we break it down, the coefficient of x was this, coefficient of y was like this, and minus z equals to a f x a b, b f y a b, minus a f a b, correct? This is what we got. Now, if this has to be parallel to xy plane, these two coefficients should be 0. Okay. So basically, what is the equation of xy plane? What is the equation of xy plane? This is from linear algebra, I am asking.
Z is equal to
Z equal to? Yeah,
Some
you are right. Z
constant.
equal to? Z equal to 0, right?
yes, sir.
Z equal to 0 is your xy plane,
Yes.
right? So basically, coefficient of x and coefficient of y are 0 here. This. Now, if two planes are parallel, then this coefficient should be in same ratio basically. So from that we are getting this fx should be 0 and fy of AB should be 0. That is why we need our gradient vector. All the coordinates of the gradient vector should be 0. Okay, clear? So it should satisfy both the equation, I mean the points, all the points which are critical point. Those points should satisfy both the equations simultaneously, right? Not only one equation for some point and another equation for some other point, not like that. It is basically all those points which satisfies both the equations simultaneously, or in case of more than two variable, all the f xi's. Okay, all the fxi's where a1 to an, that should be 0. So all those points basically. So let's see an example quickly. So suppose we have today started with this one. So let's stick to that for some time. So can we find the critical point of this? Any critical point this function have?
Yes, sir. 0, 0.
So first of all, this fx of xy is 2x. This should be 0, and fy xy is 2y, and this should be 0. Right? So from here I am getting x equal to 0, and here I am getting y equal to 0. So basically, only point which satisfy both this condition is 0 comma 0, right? There are no other point which satisfy this condition. So there is only one critical point. So this is the critical point. Now, in week 11, we will see how to find local maxima, local minima, and saddle point. But still, before going to that, what should be the definition of local maxima and local minima?
Where x is greater than 0.
Mhm.
F dash x, not f of x.
No, I am just asking. I am not asking for condition. I am asking for definition. What do you think? What should be the definition of local minima?
When basically z is the minimum and parallel to xy plane, that will be the local minimum.
So function value should be minimum at this point or maximum.
Uh, that is global, no? It may not be locally. So basically, if suppose I am doing it two variable, if this is a critical point, then take a neighborhood of it. Okay, I mean there is point A comma B. Take a open ball, or here which is open disk surrounding it. If in that open ball or in that open disk, every point xy is greater than fab, then this is minima, local minimum, right? Why it is local? I mean it is minimum in that neighborhood only. It may not be minimum globally, right? That is same type of definition we have came across in one variable calculus, right? So let me recall that thing. Suppose I have function like this. Okay. So this point, will this be a local minima?
Yes, sir.
Yes.
This will be a local minima, but is it a global minima?
No, sir.
No.
No, because there are
No.
some point where the functional value is less, right? So basically, if we take a neighborhood of around this point, if we take some neighborhood around this point, then the functional value is minimum at this point in that neighborhood. That's why it is called local. So similarly, if we see here, it is also a local minima, but if this is the domain of the function, suppose this is only the domain, then this function, this at this point is basically a global minima also. Okay, so can you find the difference between local minima and global minima? Okay, and is this a local maxima?
Yes, sir.
Yes.
Is this a local maxima?
Yes.
Yes.
Now suppose this is 1, 2, 3, which one is the global maxima?
3.
3.
3.
3.
This is the global maxima. So there is a difference between local maxima and global maxima. Similarly, local minima and global minima. So for local maxima, what should be the definition? If AB is a critical point, then I mean critical point is also not needed for this definition basically. So the definition is if we take a neighborhood of some point and all the functional values around that point is greater than the functional value at that point, then it is a minima. Uh, and if the opposite occurs, that means it is less than this AB in the neighborhood of AB, then AB is called local maximum.
Sir, I want to ask the question.
Yeah.
Sir, in this local minima,
Hmm.
you have written f of xy is greater than f of ab. Sir, let us talk about this point after the point 1, like the first minimum. Sir, where would be the like you have drawn the open ball around that point. Sir, but where would be f of ab and where would be f of xy?
No, so the picture I have drawn, that is basically one variable picture. So in this case, it will be f of x greater than f of a, right? So this is my f of a, and the ball I have taken is surrounding that. So all those values around that should be greater than f of a. Then it is minima. So if you take this, this is your f of a, and all these points around it, this is greater than f of a. Okay, then it is
Okay.
the minima.
Okay.
Clear?
Now got it. Now got it.
But how will you find the x and y, sir? Like how the range of the neighborhood?
Huh?
How should we decide the range of the neighborhood, or what points should we?
No, there should exist some neighborhood. That can be very small or large, that depends on the function.
But
Okay,
how do we
there
find?
should exist. That is the point.
But how do we find it?
So it depends, I mean, depends on the function you are dealing with. By seeing that function, by seeing the graph of the function, you have to find it. Okay.
So we
So
will
if
have.
you want to go by the definition, that is the way, but there are some other tricks, I mean, other formulas, maybe you can say, which I will show you in week 11. Basically, there is some technique. So in one variable, as you have seen, so you go to the second derivative and then you calculated it, right? Whether
Yes.
it is local maximum, local minimum. Similarly, here also you have to go to the double derivative, right? Then you can find it because you want to so not only the change of slope, the first derivative will give you the change of slope, right? But the second derivative will give you the change of slope from positive to negative or negative to positive. That you also want to know, right? Similarly here the double derivative will give you the same thing. So using the double derivative you can conclude that, otherwise you cannot. Okay, or else if you know the graph of the function, if you know how the function behaves, then you can do that, like the example I have taken. So can you tell me whether this is a minima or maxima? Any idea
It is not
It is
min.
minima.
why
At
it is
origin,
minima? Origin it's okay, but why it is minima?
It is global minima, right, sir?
It is global.
Because x square y square is above xy plane.
For any
Exactly, so
value
it
of
is
x, y,
always
it is above.
positive. It is always positive or equal to 0. So it is only equal to 0 when it is 0 comma 0. Otherwise, it is always positive, right? because it is sum of two real number, sum of square of two real numbers, so it is always positive. So it cannot be negative, and at 0 the value becomes 0. So this is actually the global minima, hence the local minima. Okay. So for this type of function, we know how it behaves. So we can conclude something. But there are some difficult functions where we cannot conclude by seeing the function only. Okay, clear?
Yes, sir.
So if you now go to this function, so now
Sir,
you can see that 0 is indeed the local minima because all the graphs are above xy plane. Yeah.
for one variable, we always
Hmm.
take f dash a is equal to 0 and we can show geometrically line parallel to x-axis. So how will show gradient f at a is equal to 0 geometrically, sir?
So that's what I have shown now here. This
Oh,
is
that's
what
what.
I was showing. So here what you need? You need your tangent plane to be parallel to xy plane, right?
Oh, tangent plane to parallel to it. That is
Huh.
why z is equal to 0.
Huh. No. Huh. Z equal to 0 is your xy plane, right?
Okay.
Z equal to 0 is your xy plane. Now what is the equation of your tangent plane? This is the equation of your tangent plane, right? Which involves the gradient, correct?
Okay. Okay.
This one.
Okay.
So
And
now these two planes should be this plane. So this is
and
your tangent plane.
this should be parallel.
This should be parallel to xy plane, this one. This is xy plane. These two planes should be parallel. Now these two planes should be parallel means this should be equal to 0 because xy plane means what? 0 into x plus 0 into y plus 1 into z. So there is a condition in 3D that two planes are parallel if this coefficient of x and coefficient of y and coefficient of z should be in same ratio. The ratio should be equal. So from there we got that fx a comma b is 0 if y a comma b should be 0. Okay, clear?
Okay,
Sir, one
sir.
more question.
Thank you, sir.
Sir,
Yeah.
while drawing an open ball around a point,
Hmm.
does it always needs to be centered on that point, or it could shift
No,
from
that is the
center?
definition of open ball around the point. So it is centering the point. I mean, if we consider open ball, otherwise there can be open neighborhood. I mean, it is not necessarily a ball. So that is what I was discussing. I mean, in
Yes,
last
sir.
live
Because
session.
in 3 dimensions we can imagine a ball, but beyond 3 dimensions we cannot imagine.
You cannot imagine, but there is a ball.
Yeah.
I mean, you can define a ball there. Right?
Yes. Yes. Yeah,
The
got
same
it, sir.
way. No issue. Because you know what are the norms there, right? You know you can define a norm there. So for defining a wall, you only need to know its radius and its center. So center is your given point, and radius you can define by the length, and length you can define by norm. So in Rn you have a norm, correct? The usual norm. So using that you can define a wall.
Okay, got it.
Yeah.
Yeah.
Okay. Okay. Fine. So basically, this till this much was the critical points. Let's see. So let's take this question and try to solve a little bit. Which one should I take? So take the first one, x cubed by 3 plus y square plus 2xy minus 6x minus 3y plus 4. Let's see what are the critical points. So let me write the function. Square plus 2xy then minus 6x minus 3y plus 4. So what should be my fx? Can someone tell me what should be my fx?
X square plus
2x, 3,
3.
3
No,
x
3 will
square.
cancel up, so
Okay,
x
3 plus
square.
Yeah,
5 is
yeah.
plus 2x, 2y,
2y
2y
2y.
minus 6.
minus
Yeah,
6.
great. What should be my fy?
2y
2y
2y.
plus
2x
2x.
plus 2x minus 3.
Okay. Everyone got this? Got till this point?
Yes, sir.
Yes, sir.
Okay. Now the
Yes,
first
sir.
option was fy, like partial derivative of f with respect to y, is a straight line passing through origin. Is it correct? Is this one passing through origin?
No, sir.
No.
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 No, it's not passing through origin, right? Okay, great. Now what we have to do? We have to find some critical points. What are the critical points? So basically, fx should be 0 and fy should be 0. So we should see what these values are. This one is one equation and this one is another equation. So can we solve it?
Yes, sir.
Yeah. So what I will do, I want you to solve yourself also. I am also solving this. So 2y is equal to 3 minus 2x. So I will substitute it here. So x square minus 2x minus 3, right? So x minus 3, x plus 1. So x equal to 3 and minus 1. This what I got. And what are the possibility for y then? So 2y is 3 minus 6. So y equal to minus 3 by 2. And so when x equal to 3 and
And y is equal to
when
half.
when x equal to minus 1, so it is 2y 3 plus half. No, right?
Oh, sir, 2.
5 by 2,
Yes.
right? 5 by 2, correct?
Yeah.
Yes, sir.
Okay. So basically 3 comma minus 3 by 2, this is one point, and minus 1 comma 5 by 2, this is another point. So these two are critical points, correct? So let's see what are the options. So these 2 points we have got, and this one is also correct because we have solved it. And this is not correct because we have solved it, basically. So this is how we solve this point. I mean, if we want to find the critical point, we can solve this, solve it like this. And then there are some other double derivative thing we have to go through to find whether these points are maxima or minima. Okay. So hopefully you have written this function. Can someone tell me so that I can draw the graph of it? Let's see what are the
Cube by 3.
X cubed by 3
1 minute, 1 minute. Let it come first. Tell me. X cubed
x
by
3
3
plus y squared,
plus y square
yeah, plus 2xy
1 minute. Y square plus 2xy
minus 6
plus 2xy minus 6x
6x minus 3y
minus 3y then
plus 4.
plus 4.
सर इतना टेढ़ा मेढ़ा फंक्शन क्यों दे रहे हो एग्जाम में?
हाँ
इतना टेढ़ा मेढ़ा फंक्शन क्यों दे रहे हो सिंपल फंक्शन दो ना सर, आसान होगा हमें.
ये एग्जाम में आया है क्या?
नहीं नहीं, not this time, but in the future you will give right. You are giving complicated functions. Give simple functions.
अब तक कोई कॉम्प्लिकेटेड फंक्शन दिया गया है?
No no no, not now.
Then why you are saying that? This is for practice, no?
Yeah yeah. I'm just scared looking at the function itself. I'm scared.
हाँ, एग्जाम में नहीं आएगा. ठीक है. So this is the function we are talking about, and what are the points we are getting? Can someone tell me?
Is 3 comma minus 3 by 2.
3 comma minus 3 by 2.
Another is minus 1 comma 5 by 2.
The 5 by 2, sorry. Right, na? 2.5.
It's right. Yeah, yeah.
Yes, sir, it's correct.
I don't know why it looked like this. Basically it will touch the function much below. Yeah. So if we put this, can someone find the value of the function? This point, because we need this point on this surface, right? This is on xy plane, all these 2 points, but we need the value of by putting x and y here. Can someone calculate it? What is the value? So if we put the first one, what should be the value? 3 minus 3 by 2. Is it really complicated something? What is it coming?
Minus 29 by 4.
So basically 27 by 4 minus 14, something like this, right?
Minus 29 by 4.
Huh?
Minus 29 by 4.
Minus 29 by 4. Okay, fine. So let me write it here. This is 3 by 2, right? Minus 29 by 4. We should. So this is the first point, this point A, this one. So now by seeing the graph, can we conclude whether this is a minima or maxima? By seeing the graph?
It's like a minima.
So local minimum.
It's a minima.
Local
Minima.
Local minima. Okay, fine. Similarly, if you put this point also, you will see some point here, then you can conclude that whether it is a minimum and maximum. So by seeing the graph, we can really conclude. And now if you draw a tangent plane at this point, that will be parallel to xy plane. That is clear, right? Clear?
Yes.
Okay, great.
Yes, sir.
Okay, great. So, yeah. And another type of problem which is important, I think, that is this last problem here. Yeah. So a function is given like this, x square plus y square plus 8, and the statement is saying the minimum value of the function is 0. Is it correct?
No,
No. What is the minimum value of this function?
it will be 8.
It will be 8. Right? Because x square plus y square always should be greater than equal to 0. So the minimum value should be 8 here. Now for the second one, the minimum value of this function. How we should do it? X square plus y square plus 8 minus 4x minus 4y. Let's write it.
Sir,
So
here
this
the
is,
minimum value means they are asking the global minimum.
yeah, the global minimum. Plus 8 minus 4x minus 4y. Because here we can find the global minima easily. That's why, basically. So can we write it like this? X 2 square. Similarly, y square.
It can be written as x minus 2 the whole square plus y minus 2 the whole
Exactly,
square, right?
exactly. That is what. So it can be written as x minus 2 whole square plus y minus 2 whole square, right? So the minimum value of the function is 0, right? Now, can you tell me at which point this minimum value is attending?
2.
2
2
comma 2.
comma 2.
2 comma
2
2.
comma 2. Correct. So this is your global minimum. Okay. So if we just give this function and say what is the global minimum of this function, you can calculate it, right? So same type of question, just we twist a little bit, we can get a new question like this. Okay. So similarly, third option is also you can write. And what about the last one? X square plus y square minus 2x plus 1. The minimum value of the function is 0. Is it correct? So this is the question. So what can we write it? We
X
can
minus
write
1
it
the whole
like
square.
this.
Yeah.
So what is the global minima? What
1
is the global minima?
1
Yeah, you are
Sir, they have
right.
asked
1
about
comma
1
0.
comma
maximum.
0.
1 0.
No, I am asking about global minima. So it is 1 comma 0 is the global minima, right?
Yes.
And what is the minimum value? 0,
0.
right?
0.
Okay. And the maximum we cannot know, right? It will go to infinity,
Yes.
right? Yeah. Okay. So this type of problem is another important type of problem which we can
So
ask.
why that answer is wrong?
Hmm.
Acha, maximum value is asking.
This is maximum value, so it is not 0. Yeah. So now the point is find the point on the plane. Some equation of plane is given which is close to origin, right? So basically what we are trying to do, so this
Are we,
type of problem.
are we trying to find the perpendicular distance?
Uh-huh. So on this plane, basically, no, not perpendicular distance. So yeah, let me write it. My 2x minus y plus 2z equal to 60. So 2x minus y plus 2z equal to 60, right? This was the equation of the plane. Yeah, right. And so suppose this is your xyz axis. We have a plane like this. This question basically is asking what is the point on the plane which has the least distance from the origin, this one. So you take any point on this plane, you take any point on this plane, x comma y comma z, and if you calculate this, the distance from origin, what will be your distance from origin of this point? It will be root over x square plus y square plus z square, right? Till
Yes.
this point it is clear? Clear to
Yeah.
everyone?
Yes, sir. Yes.
Yes,
Okay.
Yes,
sir.
sir.
Yes.
So basically this is your function.
And it has to be
You have to
minimum.
minimize it, right? But a condition is given on x, y, z. What is the condition? This. The condition given is 2x minus y plus 2z equal to 16. This is the condition given. So basically you can reduce one more variable. So you can transform your 2z as 16 minus 2x plus y. So y is, sorry, z is 8 minus x plus y by 2. Okay. Now if this function will become as a function of f, x and y, x square plus y square plus 8 minus x plus y by 2 whole square, right? Now basically if you want to minimize the square root of this, if you minimize what is inside that, that is enough. If you minimize this function, so let's write it as gxy. If you minimize this function, then it is enough, right?
Yes.
Yeah. Now you know how to find the minimization of this. Basically you have to find gx and gy. What is gx?
2x plus 2 plus x plus
2 into
Minus
this whole thing,
minus 2.
and then derivative of this within bracket with
so
respect to
minus
x.
1,
Minus
right? So this one. And what is gy?
2y
2y. Basically 2 and this half will cancel out. So eventually it will be
8.
like this. Okay. Now you should equate it to 0, move equate to 0, and you can find your x and y. And once you find your x and y, you can find your z also. Okay? Fine?
Sir, this is under root. Fxy.
But that's what I have told now. See, whatever is inside the under root, if you minimize it, if you find the minimum value of that function, then the square root will be the minimum, right? So it
Okay.
will be enough to find the minimum of this function, which is inside square root. Okay,
Yes, sir.
fine. So I
Okay.
think you can find your find the solution like this. Okay. Check this calculation. Maybe there is some calculation mistake which I have done now, but check it. Okay. So is it clear what we want to do here? So this is one important type of question which can be asked. Okay. So basically in week 10, I don't have to say I mean, anything more. So if you have any doubt, then we can discuss now on week 10. Otherwise, I don't have to say more thing here. Probably in tomorrow's session, we can start week 11, right? Tomorrow there is a session which is also dedicated to week 10. So if you don't have any doubt, then we can start week 11 tomorrow. Okay?
I have a doubt.
Sir, can we discuss questions which we could not solve in week 10?
Yeah, sure.
Thank you.
Sure. Tomorrow we
Sir,
can do that.
sir, if I have not covered, actually till now I have not covered week 11, sir.
Okay.
So,
Okay, then if
sir,
you want, we can discuss with 10 itself tomorrow.
no, sir,
But I
if
mean, there is no extra point here for discussing. That's what I was saying.
sir, I can
Yeah.
attend if even if I have not covered it.
Mm-hmm. That's okay. Fine.
Sir, one more question out of the way. Sir,
Hmm.
while checking the quizzes and the end term, sir, is it a manual checking or a computerized checking?
Checking of what?
So quizzes and the end term
It
is.
is computerized checking. It is computerized.
So actually, I have a question.
Yeah.
In 10.2, so it is
Mm-hmm.
the question is then the tangent line at the point some xyz in the direction of ABC then is parallel to the line. So what does it mean by parallel to the line?
One minute.
Bit
Let me.
confused there.
This is CT. 10, 10.2,
Yes,
right?
yes, 10.2 seventh question. Hmm, there are multiple questions there actually.
This is 10.2 seventh question.
Yeah. So what does it mean by parallel to the line?
Tangent line at the point 1 in the direction this is parallel to the line.
Or you can say the fifth question also, it is also similar.
Basically, what I was saying that if you see the direction of the vector given, the unit vector which is given. So
Okay.
here instead of unit vector, we are given a particular vector, right? We have not normalized it, right? So you have to find the normalized vector first, then you have to calculate the tangent line, correct?
Yes. So basically in
That's
the
why this parallel thing is given. I mean, it is not exactly the same thing which is in this direction, but it is parallel to that direction by using the unit vector.
so we have to first normalize the 111 vector, right?
Yeah, right. Then find the tangent line.
And then find it. So the same formula, right? It is xt and x.
Yeah, right. So here it is three variable.
So 4 it
So
will.
one more term will come, right? That is
Yes.
ut. Yeah. So basically, that's why the parallel thing is given, okay? Because we are not giving you exactly the unit vector. So we are giving you a vector, then you have to find the unit vector. So then you have to find the tangent line. Okay?
Sir, I want to ask a question from the
Hmm.
lecture, sir. When sir was discussing the parametric equation, he mentioned that for a linear algebra, any arbitrary line is an affine flat.
Hmm. Hmm.
And
Hmm.
some translation, he was talking about some translation from
Hmm.
these two origin. And so, what was this that concept? I am not able to understand it.
That I mean, in last session we have discussed in elaborately, right? What is affine flat or affine line? So basically, suppose you are in R2, okay?
Yes.
What are the possible subspaces?
Sir, zero subspace, a line, and R2
Right?
itself.
A line, any line,
A line in R2, in XY plane.
any line, any line. Is this line a subspace?
No, sir, line passing through origin.
Line passing through origin, right?
Yes.
So all the line which is passing through origin is a vector subspace. Now if you translate it, if you move the line, which is not passing through origin, then this will be a affine subspace. This is not a vector subspace, but this is a affine subspace.
Yes, sir.
That is what Sir was telling. So in R2, possible affine subspaces are all the vector subspaces are anyway affine subspace. So this line passing through origin itself is an affine subspace, but any line which don't require there is no requirement that it should pass through origin. So any line will be a affine subspace or it is called affine line. Okay. So in R3, if you see any plane passing through origin is a vector subspace, right? Two-dimensional vector subspace. Now, if you translate it, you will get some plane like this, right? This plane is not passing through origin, but it is a translation of a plane which is passing through origin.
Okay,
So
so
if you, yeah,
we can translate this plane to origin and elsewhere, right?
exactly. Then you will get the vector subspace. So this is basically your affine subspace. That's why affine subspaces were defined, right? Any
Yes,
vector subspace plus some point,
yes,
right?
right.
That's how plus some vector, maybe not point, plus some vector. That's how affine subspaces were defined, right? So this is basically the translation. This indicates the translation. Okay. So if you are given a line like this, 2x plus 3y equal to 0, this is a vector subspace, right? Now if you translate it, 2x plus 3y, parallelly you are translating, but now it's 3. So this is your affine subspace. Clear?
Yes.
Yeah. Okay. So any more doubt in this week 10? If not, then we can close this session and tomorrow again we can discuss freshly.
Yes, sir.
Basically, in week 10 and 11, there are very few concepts, but you have to visualize it. That is the main issue. And then again,
Sir,
we will start revisioning the linear algebra portion before end term. Okay?
sir, what is
Because
there
I
in
think
week
that
12,
is
sir?
required. Huh?
What is there in week 12, sir?
Week 12, there is nothing in week 12.
Okay, it's a revision.
It's a
Sir,
revision.
what is the difference between a tangent plane and a tangent hyperplane? Are they the same thing?
So hyperplane, basically, we call it when we are dealing with more than 3 dimension. Then we call it hyperplane.
Oh,
Sir, is there any assignment in week 12?
No, there is no assignment. So till week 11, everything is released. So whatever the assignment are there in the portal now, that is your assignment. So after completing week 11, as soon as you complete week 11, we can start revisioning the important week of linear algebra. That's the goal for this. Okay, so in week 12, we will basically go back to linear transformation and all those bases. Because before end term, I think we need some discussion
sir,
on
one more doubt I have.
yeah.
In linear approximations,
Mm-hmm.
sir has told that linear approximation is, say, the function value plus the directional this gradient vector into
Linear
the.
approximation is basically same as tangent plane.
Sir,
Right?
actually, my doubt is that okay, can you write sir one question, please?
Mm-hmm.
The linear approximation to f of xy equal to xy at 1, 1. Sir, why don't we need to normalize this unit vector? This is not a unit vector actually. We have to.
No. But what is your linear approximation of this? First tell me that. What is the linear approximation of a function? Hmm? So suppose in one variable, go back to one variable. Okay. So suppose I have fx equal to x square at x equal to 1. If I want to
Actually,
find the linear approximation, what is that?
it is the equation of the tangents.
It is tangent, right?
Yes.
So how we will find that? What is the equation of tangent?
First, we will find the derivative, then y minus y coordinate of the point given.
So basically, this is your derivative. So what is your equation of tangent? So f dash 1 is
y equal to 2x into x minus 1.
into.
Sir, actually, screen is fully not visible to me. Can you scroll up? Scroll. Scroll.
Yeah.
Yeah, this is
So y, you said y equal to 2x minus 1, then y minus 1, na? It should pass through 1 comma 1, right?
yes.
So this is basically like this, right? So this is the equation of the tangent you are finding, and that is your best approximation, linear approximation. So in this case, it will be tangent plane. Right? Now, when we are talking about tangent plane, we need not, I mean, why should we normalize it? This is the point given. This is not the vector in which direction we want to find some tangent line. This is not that. This is the point given. Why we should normalize it.
Okay, okay, sir.
So
Yeah,
when you
right,
normalize
right.
this, you normalize it when some
We
unit some vector is given and you need to find the unit vector.
Yeah,
But
we
here it
want
is
to go
not the
in that
case.
direction. Then we want to
Ah,
normalize.
right,
Okay, this
right.
is the point here. Right.
Yeah. Okay. So I mean, is with 10 more or less now, can you visualize yourself? Have you seen the GeoGebra links which I have posted? All of you got that?
Yes,
No, sir. Where you
You
have
have
posted?
none?
sir. You have mailed them. I received the
Yeah,
mail.
it has sent in the group mail.
Group mail. Okay.
Yeah. Have all of you got that?
Yes,
No,
sir.
sir.
Yeah, yeah, yes, sir.
Yeah, it should
Yes,
be. I
sir.
mean, we have sent it. So,
Where? Discourse forum, sir. Where
no,
it
no,
is?
not discuss from. In your group mail, we have sent it
Oh.
as an announcement. It
Okay,
went, I
okay,
think.
okay.
Okay.
Have you?
Yeah. So please go through the that GeoGebra links. Okay, all the GeoGebra links. That will be helpful to visualize this. Okay. So try to visualize all this. Try to solve the problem of week 10. Then, if there is still more doubt, then we can start week 10 tomorrow, or else we can start with week 11.
Sir,
Okay.
gradient is always perpendicular to tangent plane, sir. It is
Yeah.
always,
Right.
yeah, it is always.
Hmm. Always that.
Okay.
Yeah.
Sir, can you please tell the date when the link was sent? I mean,
Okay. That will be this one. No? 13 July. This is the mail basically.
okay, sir. Thank you.
13
Thank you.
July.
Okay, sir. Thank
Okay. So should we close the session today? Because I think no more point in
Yes, sir. It's Friday. You can go enjoy.
not enjoying. I mean, if you have doubt, I can sit here till midnight. Okay.
Thank you very much.
Yeah.
Thank you, sir.
Sir,
Thank you, sir.
regarding quiz to solutions, na, sir, please
Mm-hmm.
post and
Yeah,
WhatsApp.
Yeah,
yeah,
sure.
yeah. We
It will
definitely.
definitely help us.
Yeah,
Yeah.
thank you so much for that.
Okay. Yeah.
Thank you, sir. Goodbye.
Yeah. Good.
Sir is not there क्या? Anybody is up there? No. Okay. ये मैं बता रहा था, आज समझा रहा था. Sir is not there क्या?